So, hopefully you guys have written down what classify means. Okay, it means to arrange or organize things using common qualities, and what we're going to be doing is classifying triangles based on either their sides or their angles, okay? So, the first one we're going to go over is the acute triangle. Okay, how many of you guys remember what an acute angle is? Okay, what is it? Less than 90 degrees, right? So an acute triangle is a triangle where all of the angles are acute, okay? So on your note sheet, you're going to fill in all these details. Okay, now the numbers that are up there are just an example, okay? But we can have other acute triangles with other measures of other angles that are all less than 90 degrees. Okay, that's just one example of an acute triangle. Okay. Now, when we name a triangle, we name it by the letters in its corners, or another word for its corners are its vertices. Okay. And when we name a triangle, we do not need to order the letters in any certain order. Okay. So I could call this triangle ABC. I could also call it triangle BCA. I could call it ACB. I could call it CAB. Okay? Doesn't matter the order that I put the letters of the triangle in. Alright? So you guys know how when you're naming an angle, the letters, the order matters, right? Because remember the vertex is always in the middle letter when you name an angle. But we're not naming an angle here, we're naming a triangle, and we're naming it by its three vertices, because it has three different angles, so it has three different vertex, okay? Now, you'll see the notation here. It has like a little triangle symbol before where it says ABC. So instead of writing out the word triangle every time, we can draw that little symbol instead. And that little symbol just means triangle. So when we see that little symbol, we say the word triangle, and then we name it by its vertices, A, B, C. Does that make sense to you guys? Okay. Does anyone need more time on this one, writing down any of the important info? Yeah? Okay. All right, so let's take a look at the next type of triangle. The next type of triangle is an obtuse triangle. Okay, in the obtuse triangle, do you guys remember what an obtuse angle is? How many, like, an obtuse angle is what? More than 90 degrees, right? So an obtuse triangle is a triangle where you have exactly one of the angles is going to be an obtuse angle, okay? So in this example triangle, angle D is an obtuse angle because it's 95 degrees, right? And so that means that it's bigger than 90. So as long as you have one of the angles that is obtuse, then we call the whole triangle as obtuse, okay? Now, one way to kind of remember this is if you think of the word obese. All right, so that's one way you could remember that it's a big angle that's in there, so it's bigger than 90 degrees. Okay? All right, do you guys need more time there? Yeah? All right, let's take a look at the next triangle. Okay, next triangle, right triangle. What's the measure of the angle in a right triangle? Yeah, you have to have one angle that is exactly 90 degrees in order for it to be a right triangle, okay? So you can go ahead and fill in the example numbers for that right triangle. Remember, if it's a right triangle, there will probably be some kind of labeling with a little box in the corner that shows that it's a 90-degree angle. okay? And remember, there are also some important parts of a right triangle. So one of those important parts is the hypotenuse, right? The hypotenuse is the side directly across from the right angle. And then the other two sides are called the legs. So I'll give you guys a minute to write that stuff down. All right, so let's take a look at the next triangle type, okay? The next type is called equiangular. Can you guys say that word? Okay, so when we have an equiangular triangle, the prefix equa comes from the word equal, right? Meaning the same. And angular comes from angle, okay? So this means a triangle with all same angles. Okay, so an equiangular triangle is a triangle where every single angle is the same measure. Now, this only happens when every single angle is 60 degrees. There's no other possible measurement for the angles to be the same other than 60 degrees. So, an equiangular triangle is a triangle where all three angles are the same, and in order to be the same, they have to be 60 degrees. Okay, so because they're the same, all the angles are congruent. All right, they all have the same measurement. I'll give you guys a moment to write that down. Okay, so far all of these angles, or all these triangles we've talked about, we've been classifying by their angles. Okay, another way to classify triangles is not by their angles, but by their sides. Okay. So the first classification is a scalene triangle. A scalene triangle is a triangle in which no two sides are congruent. So that means every single side is different. None of the sides are equal. Okay? So go ahead and fill in that information for that example that you have on that scalene triangle. Give you guys a minute to finish that one. So the next type of triangle classifying by sides is isosceles triangle. Can you guys say isosceles?
Isosceles.
Okay.
Isosceles.
Okay. Isosceles triangle is a triangle in which at least two sides are congruent. Now, what do the words at least mean? That's the minimum number, right? So if it has two sides congruent, it's called isosceles. What if it has three sides congruent? No, it's still isosceles. At least means the minimum number of sides is 2. So minimum means it could be 2 or it could be 3 sides congruent, and it's still considered isosceles. Does that make sense? Okay, so fill in the information on the example for this isosceles triangle. Okay, do you guys still need a little more time there? Yeah. Okay. All right, so let's take a look at the last one, classification by sides, okay? We said if it has 2 or 3 sides congruent, it's isosceles, okay? When it has all 3 sides congruent, so in this type of triangle, an equilateral triangle, equa meaning equal, lateral meaning side to side, so lateral, equal sides, okay? When you have all 3 sides congruent, that's called an equilateral triangle. So equilateral triangle is just a special kind of isosceles triangle. Equilateral triangle is still an isosceles, okay? It's just a special kind of isosceles where all 3 are congruent, okay? All right, so I'm going to give you guys a moment to write that stuff down. I'm going to take a look at some examples that are similar to your homework that you're going to do tonight. Okay, so what I'd like you guys to do is on the next page of notes, you should be on the side that looks like this. Do you guys see that side? Okay, let's take a look at some of those example problems together. Okay? All right, so let's take a look at problem number 1. All right. So problem number 1, it says classify each triangle by its angles and its sides. So you need to have 2 different answers here. One is classifying the triangle by its angles. So let's look at the angles. Okay, we have 60, 48, 72. Are any of those angles obtuse? All right, so answer, I don't want you guys to get ahead of me, just answer my questions. Are any of those angles obtuse?
No.
No. Are any of them right? No.
Yes. No.
Okay, none of them are obtuse, none of them are right. All of them are acute. Okay, you guys were all shouting out scalene, but scalene isn't classifying it by its angles. It says first classify it by its angles, which means it's either obtuse, right, acute, or in some cases it could be acute and it could be also equiangular, right? Now, is this one equiangular? No. They're not all the same angle measure, okay? Now, after we classify it by its angles, then we're going to classify it by its sides. So, are any of the sides the same length?
No.
No, that's why it's scalene, okay? But scalene isn't classifying it by its angles. Scalene is classifying it by its sides. You need to do both on the homework, okay? So, let's look at the angles here. Are any of the angles right?
No.
Are any of them obtuse? Yeah, 112. So it's going to be an obtuse triangle. Okay? All right. After we classify it by its angles, now let's classify it by its sides. Are any of the sides congruent? How many?
2.
2. So if there's at least 2 sides congruent, that's called isosceles, right? If it had 3 sides congruent, we could say it's also equilateral, but this one is not. 2 sides congruent means isosceles. Okay? All right, there are some markings on the third one that didn't print well. I want you to mark here and here, those marks, and then also here and here. Okay, so on number 3, let's first classify by its angles. Now, there's no angle measures on here, but we're just going to use our best judgment to say, are there any right angles there? No. Are there any obtuse angles there? No, none of those look bigger than 90. So, what kind of triangle is this? Acute. Okay. Now, we're going to classify based on its sides. So, are they all different? Are 2 the same, or are 3 the same? 2. So what does that mean? Isosceles. Okay. All right. On problem number 4, the marking didn't come out good, but there is actually a mark right here, so you guys can add it in if it's not showing up on your paper. Okay, so first let's classify by its angles.
Right angle.
Yeah, it's a right triangle. Okay, and next, by its sides. Now, are any of the sides there marked congruent? No, there's no markings. So if they're not marked congruent, you cannot assume that they're congruent, so we're going to assume they're all different. So what will it be? Scalene. Okay? All right. Now, on this next part, it says identify the indicated type of triangles if these segments are congruent, and these segments are congruent, and these two are perpendicular, creating a right angle. Okay, so all these things here are marked on your paper for you. You guys see all the little marks showing what's congruent, and then you see, because these were perpendicular, there's a right angle right here. Okay, now what we're trying to do is identify, okay, first some isosceles triangles that we see in this picture.
That's a D, right?
Yes, this is a D right here, okay? All right, so let's look for some isosceles triangles, okay? So raise your hand if you think you see one. Okay, Julia?
The one in the middle, which is BDE.
Okay, so triangle BDE. Does everyone see this one? See how it has two congruent markings right here? Okay, so we can call this triangle any order of the letters. Julia said BDE, but you don't have to do that order of letters. You could do like EDB or EDD or BED. It doesn't matter. Okay? All right. Okay, do you guys see another isosceles triangle somewhere in there? Another one. Okay, Olga? ADB, is that what you said?
Yeah.
Okay, so ADB would be this triangle right here. Okay, now that one actually has three sides congruent, so that one's isosceles, and it's also what? Equilateral, right? But remember, every equilateral triangle is also an isosceles triangle because it just means at least two sides congruent. Okay. All right. Are there any other ones that you guys can see in there? Christian? Okay, so when we name it, I know which one you're talking about, Christian. We just name it by its corners or by its vertices. So its vertices are B, D, and C. E is not considered one of its vertices because it's in the middle, okay, of a segment. So you would call this one BDC. Does that make sense? Or some combination of those three letters. Okay, so good job because these two sides are congruent. Okay, so BDC. Okay? All right. Okay, so next, we're looking for scalene triangles in this figure. So remember, scalene triangles, all the sides have to be different. Raise your hand if you see a scalene triangle that you'd like to point out. Okay, Melanie? A, B, C, okay? So that's this larger triangle going all the way around the outside, right? A, B, C. Okay, does anyone see another scalene triangle in there? Renee? EDC. Do you guys see this one right here? Yeah, all of those sides are different lengths, right? All right. And I think we got all of them there then. Okay? All right. Okay, let's move on to the last topic that's going to be on your homework. Okay, so the last topic is finding the measure of the sides of this triangle and classifying it by its sides, but there's no triangle here. So what do we have to do to first be able to see the triangle? Yeah, plot the points, right? Okay, so let's go ahead and plot the points. Make sure when you're plotting the points that you're doing it accurately, because if you're not doing it accurately, that will first off mess up your whole problem, okay? So point K is at -3, +2, so that's up here. All right, point P is at +2, +1. And then point L is at -2, -3. It's down here. Okay, once we get those points onto the page, you can go ahead and connect them. Okay, now, can I just count how long this side is when it's diagonal like this? No. Like if somehow my triangle had graphed where the points were connected vertically or horizontally, I could have just counted, right? But because this one is diagonal, I can't count that. Do you guys remember from the first unit that we did this semester how we find the length of a segment that's in the coordinate plane? Okay, I heard someone say distance formula. That's one way. Does anyone remember the other way?
Good point.
So the other way is Pythagorean theorem. Okay. All right, now, in distance formula, remember you have to use the ordered pairs, and you plug them into that square root with the parentheses and the x's and the y's, and then you subtract and you add, you square, you do all this stuff, right? Okay, it's kind of a long process. If you remember Pythagorean theorem, what was Pythagorean theorem? A squared plus what? Equals c squared, right? A squared plus b squared equals c squared. Okay, I'm going to show you guys using Pythagorean theorem because I prefer this method because I feel like it's faster and less room to make mistakes. Okay, but if you like the distance formula and you remember that and you want to use it, you can use it, okay? So what we're trying to do, our end goal is trying to figure out, are any of these sides congruent? And we can't just look at it and say, oh, it looks congruent, so it must be congruent. No, we can't say that. We have to actually prove it, okay? So what I'm going to do is I'm going to take each side and I'm going to do Pythagorean theorem to find the length of that side. Now, I'm going to start out with KP. And what I'm going to do is I'm going to draw like a little right triangle here. And that's attached to side segment KP. All right? Now, on this right triangle, now I have a little right angle right here, right? I can count how long each of my legs are, and then I can plug that into my A and my B for Pythagorean theorem. And then once I solve this, it's going to tell me the length of the hypotenuse in this green right triangle, which is the C value, right? So how long was this side? 1, 2, 3, 4, 5. And how long was this side here? Just 1? Okay. So I'm going to plug in 5 squared plus 1 squared equals C squared. And I'm going to solve this. And if you guys want, you can just plug this number into your calculator and round it to the tenths place. So I'm getting about 5.1. Okay, so this side right here, its length is about 5.1. So now I know the length of that side. Does that make sense? Okay. Now I'm going to do this again, but now I'm going to do it for side LP. Okay. So this side I did up here, this one, this side was KP, right? That was for side KP. Okay, now what I'm going to do is I'm going to do for side LP. Okay. And I'm going to draw another right triangle off of that side. Here's my right angle. Okay, and I'm going to count each of those sides. So 1, 2, 3, 4, and 1, 2, 3, 4.
Would it make it negative since you went backwards?
No, because it wouldn't make it negative because when we count the length or the distance of something, do I ever say like, oh, I ran -4 miles yesterday? Like when I run, do I run out like positive and run back negative? No, I just say like that distance is a positive distance, right? Does that make sense? Okay, So now, let's go ahead and plug these ones in. So 4 squared plus 4 squared equals c squared. Okay, and now I get 16 plus 16, which is 32. And it's obvious right now that these are different lengths, right? But I'm gonna go ahead and just approximate it so I know like approximately what the length of this side is. Okay, and I get about 5.7. Okay, and so this one was LP, right? This length here was segment LP. Okay, so this length here is 5.7. That's why you only have 2 problems like this on your homework. Okay. All right, so now last, okay, let's do which segment?
K and L.
K and L. Okay, now, the cool thing that you'll notice is when you do get congruent sides, what do you notice about the side lengths of their triangles? Yeah, like this one's 5 and 1. Well, didn't I already do 5 and 1? Didn't I already do 5 squared plus 1 squared? Okay, so for side KL, do I really need to do all that work again? No, I'm going to get the same exact thing. So for side KL, the hypotenuse is about equal to what? 5.1, okay? So if you get the same side lengths that you did in the previous triangle, like you don't need to do the whole work again. So this is now 5.1. So now that I've found the length of all these sides, let's classify the triangle by its sides. What kind of triangle is it? Is it scalene? Is it isosceles? Is it equilateral? Isosceles, okay? So it is an isosceles triangle, so that would be your answer there. Okay? All right. Is that making sense there? Okay. All right, let's really quickly do number 8 together. So everyone graph your points. See if you can work ahead of me a little bit. Okay? See if you can work ahead. Try to figure some of the parts out. Okay? Make sure you're graphing accurately. If you mess up your graph in the very beginning, it makes the whole problem turn out wrong. Remember, when you graph, you always go over first, and then you go up or down second. Okay, so for me, I'm going to find side PK first. So finding side PK. I'm going to get the square root of 53. And when I put this into my calculator, I'm getting that C is approximately 7.3. Okay, so this side here is about 7.3, that one. Okay. Did anyone work ahead and get that side? Yeah? Okay. All right, now, the next one, I'll do LK next. Okay. So when I count this one, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay, so for LK, I'm getting 4 squared plus 6 squared. What's that? Okay, I'm getting 52. Now, this is very close, but is it the same number that I got above? No. Okay, so are those two sides going to be congruent? Okay. I'm just going to go ahead and figure out what the approximation is, just so I have a kind of idea. Okay, so this side over here is 7.2. Now, It looks pretty clear that the last side's not congruent, but we're gonna go ahead and find the length anyways, just to prove that it's not the same size. Okay, so that last side. This one works out to be pretty nice. What's the square root of 25? So that side's exactly 5, okay? So this first side I found, this was side PK. This side that I found, this was LK. And the last side I found, this one was LP. Now, were any of them congruent? So what type of triangle is this? Scalene. Okay. For your homework tonight, your homework is on the back side of this. Okay, so the whole back is what you're doing for homework. Okay.